So we have seen the RCNN and fast RCNN and seen the evolution of both of them, from RCNN and fast RCNN. Now, one major problem which we were seeing was it was kind of slow, and one of the predominant reason why it was slow was mostly because of the selective search algorithm which gave the region proposals. And also another problem was though it was not able to be end-to-end trained. It was not just a single network, because in, say for example, in the RCNN you had two different moving parts. One is the selective search which generated the regions of proposals, and also the SVMs which were used for classifier. So all these things were not part of the network, and these were all separate pieces altogether. And fast RCNN kind of corrected that to a certain extent, wherein the classifier was part of the network, wherein softmax and softmax plus a regressor was brought in for classifying. One is generating the classifiers for the different classes, and also give the regressors for the bounding boxes. Now, faster RCNN was an attempt to make it an end-to-end network, wherein it was possible to have an end-to-end, all these moving parts in as part of just one network. And also it tried to correct many of the earlier problems which was there in the RCNN and the fast RCNN, which was about the speed. And now let's look at those innovations which were brought into the faster RCNN. So the second part, you start off with the image, and then the feature extractor, which again is a CNN network, just like in the other networks, And then one of the greatest addition here was something called the region proposal network, which was used in place of the selective search algorithm. Now, region proposal networks were special type of networks which were used to generate the region proposals, and it gave a lot of improvement in terms of the speed than the selective search algorithm. We'll get into details of this, the dynamics of the region proposal network in the next subsequent slide. But just hold on for that. Let's go end to end. And the next one is the ROI pooling, which is similar to what we saw in the fast RCNN. And finally, the softmax and the regressor. Softmax for classifying the different classes of the object, and the regressor is for the bounding box. So these were the complete set of pieces, and as I said, the region proposal network was one of the greatest innovations. Let's see what was there in the region proposal network. So the region proposal network, the main idea behind the region proposal network was the introduction of something called the anchor boxes. Now let's understand what these anchor boxes, and before we understand what anchor boxes are, let's look at what actually happens in the feature map. Once the features are extracted, what happens in the feature map. So what was done was divide these feature maps into regions of equal pixels. Like, say for example, you create a point, say at a fixed interval. Let's say every 16 pixels we mark it as a point. So as a result, the whole feature map was divided into multiple points called the anchor points. Now, and then the other important innovation was the introduction of these anchor boxes on each of these different points. So let's look at one of these points and just expand what these anchor boxes are. Now, anchor boxes are boxes or fixed sized window boxes which were introduced at each of these anchor points, and the objective of these anchor boxes was to detect images or objects at different scales and different sizes inside a fixed window or around this anchor point. So let's look at these different boxes which we have. Now you see at the center you have a set of three sets of boxes. One is a tall box, a square box, and a wide box. And then the next set, you find the red boxes, kind of the same shapes but different sizes, and then you have these yellow boxes which were much more bigger than the other two, but the same kind of aspect ratios. So this was the idea. Now one of the major problems which were there in the selective search algorithms was, or when you have a fixed size window, was, say, suppose there are many multiple objects in the same kind of window or the same area. Say in this place, suppose there was this pothole, and there was a vehicle going, or a small vegetation here, or a signboard here. I'm just giving a fictitious example. So when all these things were there with a fixed size window, it was difficult to localize on all these three, and that's why these anchor boxes were introduced. And in the original paper, there were 9 different anchor boxes like this, of different sizes and different aspect ratios. So this was the idea, and the basic idea for these anchor boxes were to detect different objects of different sizes and scales within each of those anchor points, or within the vicinity of those each anchor point. So even in these anchor points, what was done was a fixed window was kind of slid across or moved across. A window of 3x3 size was moved across with the anchor point as a center, and then the anchor boxes were built around that anchor point to detect objects. Now after this, there was another innovation which happened. Now, even if you have a lot of these these anchor boxes, again you will have a lot of different types of objects which would be detected. And this and for the algorithm to have these efficiencies in speed, which was superior to the earlier methods like your selective search, you just had to reduce the number of anchor boxes, or number of the objects which were there. And that is what another innovation which happened in this, which we will see in the next slide.